Okay, uh, 4.4, we're talking about triangle congruency again. And the big objective today is to talk about SSS and SAS and what those really mean. We'll be proving using proofs again tomorrow in class, not today. And pretty much what we're going to be doing is today we talked about if we wanted the definition of congruent triangles is we have three sets of congruent corresponding angles. Remember, corresponding means in the same spot, matching. And we also have three sets of congruent corresponding sides. That's the definition of congruent triangles. Well, instead of having to prove all six parts are congruent, we have the shortcuts, and the shortcuts are SSS and SAS. And to start off with the first one, SSS, the property of triangle rigidity says that because the two side lengths of a triangle can't be morphed, they can't be bent or shrunk or anything, because they're the same, because they're rigid and you can't move them, then the triangle can only have one shape. So if you know the three sides of two triangles, then they have to be congruent to each other. So if I was going to, for example, and I can show you this better in class, if I have three side lengths, so let's say there's one, there's another one, and there's another one. If I cloned those, so if I cloned it, I'm copying it, and here I paste it. There's that same side length, okay? Do the same thing for this one. I copy it, I paste it. All right, cool. And then that third side, I copy it and I paste it. So this works for any triangle in the world because I can't bend these sides. It doesn't matter what I do. These triangles have to be exactly the same. They have to be congruent by side, side, side. So that's one shortcut. That's a shortcut. Instead of proving all six things are congruent to have congruent triangles, we just need to know that the two sides are going to be congruent to each other. So if I was going to write this down on my cheat sheet, on my yellow cheat sheet, I would say that if I know that three sets of corresponding sides are congruent, then those triangles are congruent to each other. So if I wanted to title this ABC and DEF, I would know that triangle ABC is congruent to triangle DEF by SSS, and that's what SSS is called. Side, side, side means. Okay, so how can we apply this? It says use SSS to prove that the triangles are congruent. So we want to explain why triangle ABC is congruent to triangle DBC. So let's look. I need to have three sets of congruent sides. All right, well, I already know, it's already given that AB is congruent to BD. Sweet. It's also already given that AC is congruent to CD. Also sweet. Where's that third side? Well, remember, BC is in both triangles. It's touching both triangles, and it's congruent to itself by the reflexive POC. So I can say that BC is congruent to BC by the reflexive POC. And thus, the triangles are congruent to each other. Cool. Another thing we can do, that's one thing, SSS. The other shortcut is SAS. And so again, our first shortcut was SSS. Our second shortcut is called SAS. And SAS it involves, if you notice, not three sides, but two sides and one angle. And this angle is called the included angle. For SAS, it needs to be an included angle. And an included angle is an angle in between two adjacent sides. And remember, adjacent means next to, touching, or neighbors. So for example, angle B in this triangle is an included angle. It's in between AB and BC, which are adjacent sides. Oops. Okay, so basically, sorry, computer rebooting. Basically, what happens, and I can show this to you in class tomorrow, is if I tell you that two sides are congruent. So let me make a triangle again. If I have two sides, one side, two side, and I know that this angle is certain. Let's make it an angle we know about. We know, let me rotate this. Actually, let me just delete this. Okay, let's do an angle that we know about. Let's do a right angle just because we know a lot about right angles. Okay, cool. Now, if I tell you guys that if I give you these two sides and I know that this angle in between those two congruent sides, those two sides is 90 degrees, I can only make one triangle. Let's see, if I connect this side, there's my triangle, okay? Now let's see if that works. So if I copy this and I paste it, okay, there's that side again, and I copy this side and I paste it, sweet, okay. And I know that this angle has to be 90 degrees. It can't be any other angle. It has to be 90 degrees. I can't switch it around. It has to be 90 degrees. Then this triangle, it has to make the same angle. It has to make the same triangle. Oops. There's no other triangle possible, and that's called SAS. There's no other triangle that will be formed. Oops, sorry, that's supposed to be a congruent triangle. These triangles are exactly congruent to each other by SAS. So SAS on that cheat sheet would say if I have two congruent sides and that included angle is congruent, then those triangles will be congruent. Okay, and this is important. It's called SAS because that angle must be included. It must be touching those two congruent sides. This angle must be touching those two congruent sides. It would not be okay if I gave you triangles that look like this. Let's say I had two congruent sides. There's one, and here's another angle. This angle is not the included angle. It would not make SAS. It would make something else. And we'll talk about that in class. So remember, SAS, these are not okay. The angle must be in between those two congruent sides. Okay, so how can we apply that? Use SAS to prove that the triangles are congruent. So here, I want to use SAS. Something that you need to look for SAS is vertical angles. Okay, so let's see. I know there has to be a side, an angle, and a side. Okay, I already know that XZ is congruent to ZV. That's given. And let's see, the other side is YZ is congruent to ZW, given. That congruent angle that I'm missing has to be in between. So it has to be this one and this one. So those are vertical angles. So I can say angle XZY is congruent to angle WZV, so that the triangles are congruent. And if I wanted to, I could write a congruency statement. So I could say triangle XZY is congruent to triangle VZW. And that means that all 6 things that we've talked about, even though they're not stated in this picture, are true. So this triangle angle has to be congruent. Let's see, angle V would have to be congruent to angle Z. Even though it doesn't say in this picture, because the triangles are congruent by SAS, that's a true statement. Okay, last thing we're going to do, verify. Verify means prove that the triangles are congruent for the given values of the variable. So this one's really easy. Triangle STU is congruent to triangle VWX. They're congruent. Why are they congruent? Well, looking at this picture, they're wanting us to use SAS to show that these triangles are congruent. How did I know SAS? Because I have a side, I have an angle, and a side. And they already told you what y equals, so you don't even have to do any algebra. Basically, UT, based on the congruency statement, UT is going to be congruent to XW. So we plug in. UT is y plus 3. XW is 7. If you plug in, you can plug in or you can solve. Y equals 4, check, that works. You do the same thing for all values. So I just did y plus 3 and 7. You're going to do the same thing for TS is congruent to WV, based again on this congruency statement. And you plug in, or substitute 2y plus 3 equals 11. And if you can solve or you can plug in. If you plug in 4, does it work? Wait, what did I do wrong here? ST is the VW. I did that right. Oh, yeah, my bad. Oh, wait, no. Oh, yeah, 2 times 4 is 8. Durr. Okay, 8 plus 3 equals 11. Sweet. Okay, and then the last one you'd have to do is the angles. So you'd have to show that if you plug in 4 here, it would equal 90. This whole angle would equal 92 degrees. Okay, that's basically what we're going to be doing. In class tomorrow, we're going to do the proofs. Yay, so excited. The 4 questions that you need to do, and I'm sorry I don't have it posted up for you guys, but written on your calendar, it says you guys need to do page 245, numbers 2, 5, and 6. And fun fact of the video, the world's most stolen food is cheese.